Okay, so this is a pretty simple program. Max entry. Again, why I choose these variable names, I have no idea. But I start out with a table of zeros, and I'm going to run 1,000 trials. And I say arrow is table tangent of random real between 0 and pi over 2. What does that mean?
That's just you're choosing a random degree between 0 and 90.
Okay. And I do that 100 times. So for each loop in my 1,000 trials, I take a tangent of 100 random reals, and then I just pick the maximum.
Okay.
And then I make a nice plot of them. Okay. So what does the plot look like? So what do you think of this distribution of the maximums here for the 1,000 trials of 100 shots? What do you think of the distribution of the maximums here?
Well, the majority of them look like they're under 200, but the ones that are above that are really, really spread out.
Yeah.
So it's sort of concentrated near the bottom, but there are a few that are like up near 800.
Now we did see the last time around that sometimes I'm not really careful with list plot, and I don't actually remember we saw for the one we did it cut off the top.
So there might be a couple even higher, but from this graph it looks like there's not going to be that many that high.
Not many above 800. Okay, so what would you guess the maximum was here?
Maybe it looks like basically 800.
Here's a little bit about that one. I think there's one above 800. I think around 825.
Okay, so I haven't even looked, so because we just ran it now. So max entry. So we'll see what the maximum was, and maybe something got cut off up top. Oh, it's actually 41,000.
Okay, well, so there are a few that, I guess, well, one that picks 89.9999.
Yeah.
It's really, really.
Okay. Are you surprised that although most of them were below 200, and then it spread out a little more, like you kind of guessed it would?
Yeah.
Are you surprised that the maximum is 41,700?
Yeah.
Well, let's run it again. Maybe that was just an anomaly.
Pretty similar distribution.
Well, is it done? Sometimes when I do things in full screen,
I think it's a new one.
it's a new one. Okay,
Yeah.
it is. All right, so let's see what the maximum was this time. Any guesses?
I'd say around the same.
I'd say a little more varied in either direction.
81,000.
That's
So
interesting.
it's really variant. It's like even you can always pick a higher one as it gets closer and closer.
Oh, here's a new one where it actually only plotted up to 600.
Just a more squished down one.
But there still could be a higher maximum. Oh, it's actually only 34.
Only 34,000 is the maximum here.
So it just kind of bounces around pretty wildly.
Yeah, so we definitely see with 100, it's not really settled down at all.
Yeah.
Do you want to try 1,000?
Could.
I
think it'll be very, like around maybe 200,000.
Okay, so this actually runs quickly. Now the plot is going up to 8,000. So we see, oh, actually, and in the bottom it's 2,000, so it's squished down here. What would you guess the maximum is?
I'd say the max is still going to be kind of around the same, and it's not going to increase.
What do you mean the same?
Like in this
Give me a number.
general 50,000 range.
Okay.
Oh, I'd say 200,000. I'd say a lot higher.
So it's still going to stay around 50,000.
823,000.
So a lot
wild.
higher.
All right, so now we'll just do it 1,000,000 times. But I'm going to only do one run of 1,000,000. Okay, and then whenever that's done, we'll do max. Actually, I'll just put it in it. Any guesses?
I'd say maybe 5 million. Oh, well, it's actually lower. It's lower.
So this doesn't seem to settle at all.
Yeah, so running it again with 1,000,000, so 566,000.
So it
927,000.
does seem to cap off eventually.
390,000. 238,000.
Well, it's not really settling anywhere.
4.8 million.
It's pretty high.
Not only is
That's
that pretty
my
high,
higher
that's higher than
previous.
that's higher than the sum of all the maxes we saw before combined.
Mm-hmm.
Would have been one extremely close.
So I guess the larger the number of runs you do is, the more chance it has to go big, and it can go as big as it wants to, basically.
Yeah, so what do you think on this distribution? If you did 100 runs and you saw the maximum, even if you saw the maximum was 48,000, do you think you would have a good guess as to what that distribution you weren't seeing was? Do you think you could say, all right, I did it 100 times and the maximum I saw was 48,000. So if I do it 1,000,000 times, the maximum will, I think, be...
You can't really say.
Yeah, you can't really say. So this is a distribution that you just can't say anything about.
That's probably because you have the component of the infinity here. Because you have an infinite.
Well, remember, we had the component that we had the possibility with our coupon collector problem that it would take an infinite amount of time as well, right? In theory, we could, if we were trying to roll a dice and get all the numbers 1, 2, 3, 4, 5, it was a 5-sided dice. In theory, a fair dice might never just roll a 5. It might take, 4.8 million trials till you see it. Do you think that could happen?
No.
I mean, it could. But the probability is so low that it basically won't happen.
Yeah, but now this arrow shooting problem, I take a random number near 90 degrees, and what happens?
It goes extremely.
It goes into the millions. It goes very far.
So here's a problem. So that we've looked at the two ends of the spectrum. One is something where you actually can almost write down explicit formulas for how the amount you're missing is decreasing over time. If you have a nice distribution, like we did in the coupon collector problem. And this is the extreme opposite end, where there's nothing you can say here. Even after 1,000,000 trials, it's still varying all over the place. So, and what Nassim is studying is in the middle of this, where you actually are able to say things, but the things are very difficult to say. So we're going to skip that, but I wanted you to see this problem, because oftentimes when you're looking at problems, the most important thing is what?
Just what you can say about the problem
What
and
you can
predicting.
see.
What you can see?
But what you can't see.
What you can't see. What you can't see is sometimes the most important piece of the problem. What you see and what you don't see. So you have to, anytime you're doing statistics, you always have to be thinking like, well, what did I not see here? And will it matter? And sometimes it does. And
Sometimes it
sometimes
really
it doesn't. The coupon collector problem, it didn't matter that much. With the arrow shooting problem,
It mattered a lot.
it mattered a lot. All right, good job, guys.